give me some information you know about this situation. You're tossing the ball back and forth. Paul?
10 feet away from each other.
Good. 10 feet away from each other. Killian?
The maximum height is 6 feet.
Right. And if that's a maximum, we're dealing with a parabola. So our parabola is going to look something like this. Adam, what were you going to say?
They catch it at waist level.
Okay, and that waist level is how high?
3 feet.
Right. So if you would think about this being on a coordinate grid, we could call the point where the boy catches it, what? As an ordered pair. Killian? That one wouldn't be our axis of symmetry. That would just be a point. What would the x and the y values of that point be? 0, 3, right? So what would the point where the girl catches it, what would that be as an ordered pair? Lindsay?
10.
Right, because they threw it 10 feet, so that's going to be on your x-axis 10 feet, and then up 3 feet because that's where she's catching it, at her waist 3 feet above the ground. We know one more characteristic of this parabola. What is it? Lindsay?
The vertex is 6, 5. Wait,
Other way around.
5, 6.
Yes. We have a vertex here at 5, 6. And that's where our axis of symmetry would lie. So we have 3 points here. It says, what's the equation in standard form that models the path of this ball? Explain your reasoning. We don't really know yet. All we know is we have 3 points. But that's what we're going to do today. We're going to find out if I have 3 points, how can I write the equation of a parabola? So we're going to come back to this and answer it. But right now, we're just going to say we have 3 points. Now where do we go from there? And that takes us to problem number 1. A parabola contains the points, just meaning it passes through the points 0, 0, -1, -2, and 1, 6. What's the equation of this parabola in standard form? Well, recall standard form. Y equals ax squared plus bx plus c. If we're going to write standard form, then we need a, b, and c values. And this is how we're going to find them. We're going to set up 3 different equations. The first time, we're going to use 0, 0 as our x and y. And then we're going to use -1, -2 as our x and y. And then we're going to use 1, 6 as our x and our y. So for the first equation, y equals ax squared plus bx plus c. My y is 0. Y equals ax, well my x is 0 as well, ax squared plus bx plus c. So we have a times 0 plus b times 0 plus c. And you guys know anything times 0 is just 0. So 0 equals c. Now we need to do this equation again. y equals ax squared plus bx plus what?
0.
0, good. Because we would be adding c on, but we just found out our c is 0. So plus 0, because that is your c value. So negative 2 equals negative 1 squared is a positive 1, just giving us a minus b. And now we have one more to set up. Y, which is 6, equals ax squared plus bx plus c. So 6 equals a plus b. All right, now we've got two equations with two variables, and I want to find those variables. Does anybody remember what process we could use? Caleb?
I'm gonna take a stab in the dark.
Okay.
Because is it when you cancel them out?
Yeah, it's whenever you use elimination with systems of equations. Create a system of equations. Use these two equations and create a system. So we're using these and making ourselves a system. A minus b equals negative 2, and a plus b equals 6. Now, Caleb said it's when you cancel them out, and luckily, we can cancel these out really easily here because we already have opposites. If we add the two systems together, we get 2a. The b's cancel, equals 4. Divide both sides by 2. A is 2. Don't forget about going back to find your other variable. If a is 2, then we can find that b is 4. And we have a, b, and c.
I didn't do it.
Hello? Hi. Sure, no problem. All right, thank you. No problem. Bye-bye. Now we can write our standard form of the equation. Here's standard form up here. So y equals a, we have it. X squared plus b, we found that. C is 0. You can write plus 0 if you want to. Do you think you need it? No. If you don't want to write plus 0, you don't need it because it's just a 0. So there is your standard form. After all that work, here's your standard form.
Is that the answer?
That's the answer. Because it's saying what is the equation in standard form, and that is a standard form equation. You're supposed to stop at the library on your way to your next class.
Okay.
All right, let's try another one. What's the equation of this parabola? We have the points 0, 0, 1, negative 2, and negative 1, negative 4. So from standard form, we're going to fill in 0, 0 for x and y. Y equals ax squared plus bx plus c. Again, this works out pretty nicely for us. We have 0 plus c, so c is just 0 again. Will it always be 0? No, not necessarily. Now in your next equation, you have new x's and y's. Now your x is 1 and your y is negative 2. So negative 2 equals a times x squared plus bx plus c, which is 0. So now we have negative 2 equals a plus b. And that's as far as we can go because we can't solve it any more than that. And then in our last equation, x is negative 1, y is negative 4. Negative 4 equals a x squared plus bx plus c. Negative 1 squared is always going to be positive, so negative 4 equals a. B times negative 1 gives you minus b. Now you have two equations with both a and b in them, so that creates a new system for you. A plus b equals negative 2. And a minus b equals negative 4. I'm going to add my systems together. 2a, b's are eliminated, equals negative 6. So a is negative 3. If you plug that back in, negative 4 equals negative 3 minus b. Negative 1 equals negative b. So b is 1. Use a, b, and c to write your standard form. Anybody want to write the standard form for me? Killian?
Y equals negative 3 times x squared minus 1x.
What'd you say about the x?
Negative 1x.
Is it negative or positive? Look at your b value.
I have a negative. It's positive. Oh.
It should be positive. So we're going to do plus x and plus 0 if you like, or just leave it like this because you don't need the 0. Yeah, where'd you plug your negative 3 back in?
I did. I just
You just did it in your head. Yeah, that's all. It was just the negative sign.